Well, my proposal is about digital twin, and digital twin is a cyber counterpart of the physical system, which is constantly updated with the performance of the physical entity based on real-time data and information. The aim of digital twin is providing healthy status for the physical entity and also providing proactive maintenance strategies. Besides general framework of digital twin and its four main characteristics, there are a breakdown between digital twins because of four main barriers. The first barrier is interoperability barrier. The second one is fragmented data standards, semantic gap, and massive unstructured data. These barriers cost us knowledge, which is the most significant organizational source. And our thinking, based on my own experience, if we could use the ontology and semantic web and connect these two twins semantically, we may flourish. And when I was searching through the literature, I noticed that scientists already take care of these barriers by providing a concept by the name of cognitive digital twin. So I developed a proposal named Grounded and Verifiable Large Language Model Reasoning for Digital Twin-Based Asset Management and Information System Approach. Through literature review and by comparison of core technology, I define five main research gaps: lack of semantic interoperability, lack of real-world validation in digital twin environment, lack of multimodal integration, lack of verification mechanism, and lack of grounded reasoning in large language models. So, based on this objective, I developed this framework. The first step of this framework is information requirement framework. We need to define what data we need, the level of detail of the data, and the format of the data. At the next layer, at the data layer, we need to gather raw data from BIM, IoT, and logs. And we need to structure these data at asset information model layer. At the digital twin layer, we need to use the asset information model for real-time syncing and simulation. And through these layers, we need to use the ISO 19650 for managing, validating, and governing the whole process. Then we need to use a knowledge graph to give meaning and reasoning to the data, and after that, we need to return to asset information models for any possible refining. For instance, we map BIM elements to knowledge graph nodes, we map IoT data to knowledge graph attributes, and we map maintenance logs for semantic entities. For retrieval augmented generation, however, we search among maintenance manuals and logs and knowledge graph data for ranking relevant documents. Then we construct context by these documents, digital twin state, and sensor data. And finally, we generate response to feed into large language models. At the verification layer, we need to do data consistency check, rule-based verification, and knowledge graph validation. And finally, at the application layer, we need to develop dashboard, chat interface, and alert system. We need to define case studies, scenarios, tasks, and execute a workflow. We need to define metrics for technicality, operational metrics, and human metrics. And I can propose five main contributions by this proposal: a novel cognitive digital twin architecture, a novel asset information model, a verifiable large language model framework, multimodal integration, and a novel cognitive asset information system. In fact, we need to develop an own information system for managing, processing, governing, and delivering asset information across the whole life cycle, with the purpose of enabling digital twin operations and large language model-based decision support. There are four main barriers in adoption of cognitive digital twin. The first three barriers reflects its complexity, but the last barrier, maintenance the system, is a barrier across the whole industry. For instance, when I was working for PC construction, I noticed that even top layer management ignored to maintain their system, and after a while, their system malfunction. So I believe systems are alive and we need to take care of them every single day. And the best case scenario is when we taught a system to take care of it itself. We can choose several names for this proposal, But for me, it's from knowledge management to knowledge management in the construction industry since 2013. At first, we need to get through literature review, and I need to develop a BIM information requirement framework based on ISO 9650 and my purposes. Thank you so much.